Hello everybody, hope everybody out there can hear me okay. I'm Steph from Simply Rhino and I'd like to welcome you to the first webinar in this series, which we're going to focus on Rhino for Mac. Today's webinar, it will last approximately 30 minutes and our presenter is Phil. Phil Cook's an experienced product design professional and he's Simply Rhino's senior trainer. As we progress through the presentation today, please type any questions you may have and send them over to us. It's most likely that we'll answer these questions in our official Q&A session at the end, but if we can answer any as we go through the actual presentation, we will. Please also note that today's webinar is live and Rhino for Mac is in development, so if there are any software hitches as we progress through the presentation, then please bear with us. Today's webinar is being recorded, so you can watch it again, and it will be posted on our Rhino for Mac YouTube channel, and a link to that is available on the Rhino for Mac page on the Simply Rhino website. So that's all from me, and I'm going to hand over to Phil now for the presentation. Over to you, please, Phil.
Thank you. Morning, everybody. My name's Phil Cook from Simply Rhino, and this morning we're going to take a quick look at some Rhino for Mac basics, and we're going to do this in the context of product design. And this webinar is really going to cover how we kind of transition from either sketches or maybe 2D Illustrator line work, bringing or creating new curves in Rhino, and then setting these out into some 3D space so that we can start to build some surfaces. So most product designers who are not yet into 3D would generally start their projects with some sort of sketching. Actually, whether you're into 3D or not, generally sketching is the start for most work. So if we have plan and elevational sketches that are proportionally correct, like the image that we can see on screen at the moment, then it's possible to bring these in a slightly cleaned up version into Rhino and use these as a reference to sketch over. Also, if we've got 2D line work that we've maybe done some formal presentations with in something like Illustrator, then again the vectors can come into to Rhino. So before we start with the actual model, let's just open a new file here in Rhino. And let's bring in an Illustrator file just so you can see quite what happens. This is the Illustrator file that you just saw the screenshot of, and it contains some fills and some blends. We are prompted when we bring in the Illustrator file to set the scale, so Rhino will use exactly, bring in the line work at exactly the same size that it's created at in Illustrator, and we can bring this straight into Rhino. Here's the layout that we have here. You can see there's a little area that's missing here, and this is where we had a blend which didn't have an edge defined in the same way as these edges. And one of the things we can very quickly do with existing line work is that we can go to curve and extend curve by line, for example, here, and we can just extend these existing curves here and close up our geometry. Okay, let's just do this with this one here as well. Okay, so the Illustrator curves essentially come in exactly as they are drawn in Illustrator. So if I turn on the control points in Rhino, you'll see where the nodes would be in Illustrator. So it's pretty much a lossless translation from Illustrator to Rhino, and vice versa as well. So the two programs play very well with each other, and Rhino reads the cubic Beziers that Illustrator creates exactly in the same way as they were intended. So another way of getting information into Rhino is essentially to bring in our sketch work. So here we've got a model that has some sort of a start to it. And one of the things that I generally suggest to our customers is that when we are starting from scratch with a model, whatever it is, whether it's a chair or in this case a phone handset or a car or some building components, then generally if we're going to create some curves in 3D space, it's always a good idea to create a 3D bounding box, which essentially defines the extents in X, Y, and Z of the model that we're going to create. And this can be a useful reference to append, for example, our sketches to, and later on to append our curves to. So I'm going to first of all just switch to a wireframe view here, and I'm going to switch layer here to elevation. You'll see that I've got some pre-built layers in this file, and I'm going to use a command called picture frame, and this is a command that allows us to bring in an existing sketch or bitmap image, and if this image is cropped to the correct ratio of the side of the bounding box that we're going to append it to, then we can essentially create this at full size. So I'm going to use the JPEG image here called elevation, and I'm going to use the vertical option here on picture frame and just snap this image to the size of the box. So the idea behind this image is that it's just a cleaned up version of the sketch that I showed you before, and it's been cropped to its extremities. So in other words, it's a kind of mirrors the side of the bounding box. Okay, I'm going to put another image in here, which is the essentially the underside of the phone now. So I'll repeat the bounding box command. Thing to notice here is that you can set Rhino up to right-click to repeat the last command. This is kind of standard Windows behavior, and if you are using both platforms, then this means that you can run the last command just simply by right-clicking. So I'll use the plan view here, and this time I'll pull in the view here, and you'll see that I've actually put that the wrong way around, so I'll delete that and rerun picture frame and try and get this right this time. Oops, didn't quite do that right. Let's do that one more time. So again, right-clicking to rerun picture frame. Okay, that's better. So now we can see the keyboard here, and we can see the side elevation. So in the case of this object, which is fairly simple, we perhaps don't need too much in the way of sketch reference. One of the things that we can do, because these picture frame objects are essentially Rhino surfaces, is that we can move these from layer to layer, which enables us to control the visibility of the objects a little better. So we'll just do this now. And I'm going to turn off the visibility of the plan here, and I'm going to turn off the visibility of the bounding box and make this new layer, which is called Curves 2D, an active layer. Okay, so I'm going to concentrate on the side elevation first of all here to create some basic curves. Before I do this, I'm just going to select my picture frame here and go to the object properties, and I'm going to edit the material that's used for this, which is essentially the image that we created, and I'm just going to give this some transparency here, just to knock this back a little bit. Okay, this will make it easier now to see my curves when I draw on this. I'm now going to lock the picture frame layers so that now I can't actually pick them and drag them by mistake. And I can now sketch in place here. Now, the side elevation for this handset is extremely simple. It essentially consists of a couple of straight lines with sort of an S-shape curve which is tangent to each of the lines that connects both of them. And actually, to create this geometry in Rhino, I probably really only need to define one of these curves. So I'm going to choose a curve here which is at the top of the lower part of the split line here. So I'm going to draw just a line here, and I can just draw along here, finish here, and I'm going to draw another line here. Now, at the moment I have the ortho constraint on, and when I draw a line with the ortho constraint on, I'm constrained by default to 90 degrees to the active construction plane that I'm working to. I can temporarily disable the ortho constraint by holding down Shift, and very often this is much easier than actually going back to the top here and turning this off. So I'm going to draw my second line here, just temporarily disable the ortho constraint here, zoom in and snap in my line. Okay, and now I'm actually going to create the curved section here, and I'm going to do this not by creating a curve manually, but I'm kind of going to ask Rhino for a bit of help to do this, and I'm going to use a command called adjustable curve blend. This is a really useful command in Rhino, and it's located here. If you just expand the fillet curve menu, and I can essentially pick a pair of curves that I want to blend, and Rhino will create a new curve for me. Okay, and when this curve has been, or whilst I'm in preview for this curve, I can pull on these curve handles here, and you see that I can adjust the shape of the curve. But while I'm adjusting the shape of the curve here, the tangent relationships at point 1 and 2 that you can see on the screen here are fixed. So I can play with this shape without worrying about pulling the points 1 and 2 out of tangency. When I'm happy with this, I can just click OK. Okay, let's just briefly turn off the picture frame layer so that you can see that resulting curve. There is an option in the blend curve command to actually join the curves together. So you can see now I've got a nice center profile for my handset. Okay, let's now look at creating the curves that are essentially going to create the cross section. If I just quickly return to my bounding box and switch to a 4-view mode here, we can just quickly check the length of this edge here, and Rhino will report that that's 45 millimeters. So that's all I need to know here in order to create the length. Let's go back to this view, the front view here, and let's create my my cross section. Before I do that, I've just noticed that I missed out a command here. I didn't have the project constraint on here when I created this curve, and as a result my curve is three-dimensional. So I'm just going to flatten this out using the project to C-plane command. Okay, so let's now create our cross-sectional shape, which is roughly speaking something like this. and let's just sketch in where we think our cross sections are going to be. So let's come across here, and for our split line is about here. So again, just lines I'm putting in here, nothing more than that. Okay, so what we have here essentially is a bounding box here that describes the top, and a bounding box here that describes the bottom molding. And I can now just remove these. So you can see the two areas here that describe the top and the bottom molding. Now, both the top and the bottom of this product have got some curvature to them. So I'm just going to, again, work off this view here just very roughly and create what I think is going to be the bottom of the curve, and then I can use an arc tool here, arc, start, end, point on arc, to just create the curve here. Okay, so that's the top curve, and again with a little bit of reference geometry here, I can mirror that curve to create the curve on the bottom. So one of the things that you try to do when you are creating simple models is to really reduce the amount of drawing and modeling that's necessary. So if you can mirror something, it's always better than modeling it again. And we're going to use a similar approach here for our side curves. So I'm just going to describe again the base of the side curve here, and I'm going to draw my arc. Just need a bit more reference here to do this. Okay, so I'm going to draw my arc here. Let's try again with the right command. Okay, and we'll mirror that arc about the center here, and just make sure that all these four curves are sat on the same height. So I'll just use project to C-plane again to do that, and then I can just trim these curves with each other here, or I can use a command called connect to join these two curves together. Okay, so you can see these corners being joined together now. So when I have the corners together, one of the things that I want to do here, because the top and bottom of my model are going to be created from different types of material, is I actually want to model the top and bottom separately from each other. So I'm going to actually create a little a line across here and a line across here, and then just for the sake of clarity I can remove these curves that we used to set up here, and I'm going to split the well, first of all, let's join these four curves together. We can do this using the join command, which is the one that looks like a jigsaw here. Rhino will report at the bottom here that four curves have joined into one closed curve, and then I can use a command called split to split this object with these two curves, this being the result. Okay, so now these can come out, and this little area here can come out too. So just a couple of other things I need to do now is that I can again create a line here, endpoint to endpoint. See, the snaps in Rhino make it really easy to actually align my geometry here. And one of the things I'm going to do here is that the piece of that's going to define the split here, I'm actually going to model this separately. And the reason for doing this will become clear as we progress with this exercise. Okay, so we now have 3 volumes, 3 closed, sorry, not volumes, 3 closed curves. Or we will do when I join them up. So bottom area, top molding, and the part that's going to define the split line. Okay, so when we have now some curves in 2D, it's pretty easy in Rhino to start to set these out into 3 dimensions. And I'm just going to turn off the visibility of the picture frame and make sure that these curves that I drew here are actually sitting on the right layer. Make this layer active here. And just want to show you how we can start to align these curves in 3D space. So first thing I'm going to do here is to move this set of cross-section curves here onto the top construction plane. So pick these. To do this, I'm going to use a transform command, and it's called Orient Remap to C-plane. And it just basically takes the geometry and moves it from one construction plane to another. Then I'm just going to rotate this round through 90 degrees. Okay, so really nice command that we can use now to start to orient our geometry is called Orient Perpendicular to Curve. And this command works like this. So it's a transform command, and it's orient and perpendicular to curve. I'm going to pick the 3 objects that I want to orient, and then Rhino prompts me for the base point. This is going to be the point that I want to lie on the curve. And if you remember when we set out this side curve here, this side profile curve here, this was the top of the lower split line. So I can just snap to the midpoint of that and then snap to this point here, and you'll see how this command aligns the curve perpendicular to my rail, if you like. Now there's a copy option on this command, and there's some options to flip and rotate here, but I'm just really interested in the copy command here. Okay, so we're going to actually cover creating these surfaces in a little more set out in a later webinar, but just to quickly just explain why we're doing this is that to create some very quick surfaces now, we can use a command called sweep one rail, and we can pick a rail, and then we can pick a cross section or a number of cross sections, sorry, just one cross section at a time here, and we can sweep these curves over the rail. And if I just shade this up, you'll see the result that we get here. This gives us open volumes, but it's very easy to go to our solid menu and to use a command called cap plane the holes to fill those ends in. So you can see that all the work really in this is put into just creating some curves, which are fairly simplistic but nevertheless precise. And once we've put those in their correct 3D position, generating the shape becomes very easy. So in the next session, what we intend to look at is to position the volume that represents the split line accurately, and then we're going to start to soften this shape. But before we do that, we're also going to look at how we can actually adjust this shape once we've actually created the surfaces. And this is a very interesting way of working, particularly when we're at a concept stage that allows us to play with the forms. So I guess that's pretty much what I wanted to cover today, so I'll hand back to Steph to see what questions we have.
Thanks, Phil. That's great. Right, yeah, we do have some questions. I'm going to hand over to Paul for those. He's going to go through those with you. If anyone else has got any more, then please send over, and we'll try and get through those as well during a quick sort of 5-minute Q&A now. And any that we can't get back to live, then we'll make sure we get back to everybody with an email. So I'll go over to Paul now, and he can get back to you, Phil, with questions.
Okay.
Hi, Phil. Yeah, thanks.
Hi.
Thanks for that. Yeah, a few questions. Command line. I guess this is a question from someone who's using or seen Rhino for Windows, because they're asking where is the command line.
Yes. Well, actually, it's here, but there's actually no need to actually click inside this window and start typing. Wherever you are in Rhino, even if you don't have this section enabled, so even if you're working in a more full screen mode here, I can just start typing. So I can type in, for example, picture frame. This will just bring up the left-hand window here with the command line in it, and it auto completes in the same way that the Windows command does. So it's if you're used to working with the Windows version, then and you don't know where all the commands are in Rhino, just don't even worry about where the command line is. Just start typing the command, and the command line will pop up.
Okay, that's great. Something else here. Yeah, a question about importing lines from another CAD package, say 2D lines from AutoCAD, for instance.
Okay, yeah, so Rhino will read DXF and DWG formats from AutoCAD, and the importation is very similar to the Illustrator process that we showed. So if you've drawn lines or arcs or splines in AutoCAD, they will come through exactly in the same way that you drew them in AutoCAD into Rhino. So it's a lossless way of bringing in the data.
Okay, and I think there's just one more. Right, about Mac interface. Can you make the Rhino for Mac interface more like the Rhino for Windows interface? This question is from Bill.
Yes, you can. You can go to Rhinoceros and let me think where we do this, preferences, and we can go to themes, and we can select either a Rhino for Mac or a Rhino for Windows theme. And if I open a new modeling window now, that will have the familiar viewport tabs that we see inside the Windows version.
Okay.
It probably makes more sense, though, Bill, to use the Mac interface, because if you're used to using a Mac, it's a much smoother, quicker way of working.
Okay, that was the last of the questions, but feel free, anybody, to email us. I think you'll have our details and Steph's contact details with any other questions, and we will respond to all of those. And please remember to join us for the second of this in the series of these webinars on the, as you can see on the screen there, 15th of April, where Phil will continue with the same model. I think that's it from us. So thank you, everybody, for joining us. I hope you enjoyed that. Thank you, Phil. And,
no problem. Thanks very much.
And maybe see you online soon. Bye.
Thank you.